function by substitution. And so first of all, we're going to look at that theorem 4.12. Basically states let g be a function whose range is an interval I, and let f be a function that is continuous on I. If g is differentiable on its domain, and f is an antiderivative of f on I, then. Now basically, I know you're probably right now utterly confused. What I want you to do is I want you to look at the bottom line there. And I want you to look at this. The integral of f of u du equals f of u plus c. Now, if you're wondering about this u, is this the u that's the same as when we did derivatives? And the answer is yes. Okay, that's why we learned it back with derivatives, so that now when you get to the u substitution, you're familiar with it, and it's not as difficult. And so on the next slide, what we're going to do is we're going to look at instances in where a u is useful, or actually necessary. And so if I look at letter A, okay, directions say the integrand in each of the following integrals fits the pattern f of g of x times g prime x. So basically, f of u du is what that represents. Identify the pattern and use the result to evaluate the integral. So basically, what I'm going to have to do now is identify u and du. So remember, du is the derivative of u. So in this case, just for kicks in letter A, what do you think you're going to let u equal? X squared plus 1. Very good. Oops, let's try that one again. So in this case, I have u equals x squared plus 1. Du then is the derivative of u, which is 2x dx. Okay? So all we're doing now is identifying u and du. Because you always attach a dx, because when I rewrite this integrand, I want to remove everything in terms of x, and I want to have u only. We'll take care of that. This right now, we're just going to identify u and du. So on this one, what am I going to let u equal? X cubed plus 1. What's du? 3x squared dx. Okay. What is u on the last one? Tangent x plus 3. What is du? Secant squared. Okay? Now if you notice, the next three are real similar. But what's the difference with letter D versus letter A? It's not 2x, but we can still do a u substitution with this. Okay? So u in this case is still going to be x squared plus 1. Okay? Du is actually going to be 2x dx. So what I would do with this problem is I need to make this x a 2. Now, the only way I can do that is to not alter the problem any. So if I multiply the inside by 2, I'm going to put a 1/2 on the outside. Why do you think I put a 1/2? It's the reciprocal, and what happens when you multiply 1/2 and 2? They cancel and you have 1. So you really have not adjusted the problem any. Okay? What's u here?
X cubed plus 1.
X cubed plus 1. Du is 3x squared dx. So in this problem, I need the x squared to be a 3. And then I'm going to put a 1/3 because I don't want to alter the problem any. Because du is 3x squared. And this has to match this.
I thought you were just matching the top.
No, we're matching. So here we go. What's u here going to be? Tangent x plus 3. Derivative of tangent is secant squared x dx. Now, if you notice, this is a 2 secant squared. So you know what I'm going to do?
You're good.
Divide by 2 on
Okay.
the side.
You know what, the easy way?
Oh,
Just move the 2 out. Otherwise, you could divide by 2, which is what some of you said, and then you would multiply by 2 on the outside. It's the same thing. So now, we've got some guidelines for doing U substitution. We're going to go through these, and then we're going to jump into some examples. So the first step, choose a substitution U equals. That's exactly what we've just done. Usually, it is best to choose the inner part of a composite function, such as a quantity raised to a power. So when you're doing your U substitutions, you're looking for quantities. And that's what we did in A through F. Step 2, compute du, which is what we did. We've already done du. That's the derivative. Rewrite the integral in terms of the variable u. We haven't done this quite yet. We'll do this in the next example. Find the resulting integral in terms of u. And then the last step is to replace u by what you use the substitution for. Okay? So let's go ahead and look at our very first step here. Okay, I've got to do a u substitution. What am I going to let u equal? X squared plus 1. Du is
2x
dx. So that is the very first step. Now what we're going to do is we're going to rewrite the integral using nothing more than u and du. So first of all, I realize I've got u here to the second power. This is represented with du. So I have rewritten the whole integral as u squared times du.
So 2x is for u.
Yes, right there, 2x dx. So now if I integrate u squared in terms of u, I'm going to use my general power rule. So this is u to the third divided by 3 plus c. Okay, why do I have a plus c on this problem? It's antiderivative and there are no limits. Remember, if I would have had numbers here, that's when you would have evaluated it. But if you don't have the numbers, you need the plus c. And then the last and final step, whatever u is, you're going to plug in right there. So in this case, I've got x squared plus 1 quantity cubed divided by 3 plus c. All right, so let's look at another one. Find the integral of 5 cosine of 5x. So what do you think you're going to let u equal? Close. Just 5x. Now the reason why we don't let it equal cosine of 5x is what's the derivative of cosine? Sine. Do I have a sine somewhere in that problem? No. So we're just going to let u equal 5x. du, what's the derivative of 5x? 5 and dx. So now let's look at what I have. If I rewrite my integral, I have the cosine of 5x, but it's actually cosine of u. So that is now taken out this part. Look at what's left. 5 dx is the only part left, and that is symbolized by du. Okay. What 5? Right. Look at what I took. Cosine of 5x corresponds to cosine of u. Right? This and this correspond. Correct? Look at what else is left. So this is what's left, right? Well, that is symbolized by du. Okay, so really I've still got everything there. I've just rewritten it. So now the integral of cosine of u, from your sheet, what do you know the integral of cosine is? Sine. Now, do you always wonder why on that integral sheet it said like sine of u, cosine of u, tangent of u? This is why. Okay, so sine of u plus c. Last and final step then. Yep, last step is to plug that in. I didn't leave the du out. The du is necessary because in order for you to properly integrate, you have to have that part. That's the variable of integration. If you remember when we started integration, it was like the integral of 5x dx, the integral of x squared dx. You've always got to have this part. All right, so let's look at this next one. We're probably going to look at 2 more on this first page and be done for today. So, what are you going to let u equal on this one?
X squared plus 1.
X squared plus 1. Good. Du is dx. Very good. So then now, let's look here. I have the integral of, what's this going to give me? U squared. Now if you look, in order for me to attach du, I need a 2x dx.
You have to add the 2.
So I've got to add the 2 here and the 1/2 here. So the 1/2 stays on the outside, and this here gives me du. Okay. So then now the question is, what do you do with the 1/2? We're just going to leave it out front for now, and I'm going to go ahead and integrate u squared. Integral of u squared is
X squared plus 1.
u cubed over 3. So last but not least, let's substitute u in. So I know u is x squared plus 1 cubed, all divided by what?
3.
Close.
6.
All divided by 6 plus c. So basically, I kind of combined those 2 steps to simplify it into one. All right, we're going to look at the next one, and that'll be the last one we look at today, and then we'll continue later. So let's look at the next one. U is
Back on.
2x minus 1. Du is 2 dx. Okay, so I'm finding the integral of u to the 1/2. Good.
You can't do root.
You could do root, but you're going to have to switch it to the 1/2 power anyway, so you're better to just switch it now. And so notice I need a 2 dx, so I'm going to need a 2 inside and a 1/2 out. So once I add that 1/2, I can go ahead and place my du. And so then now, let's go ahead and add 1 to 1/2, and what do I get?
2 3 halves.
3/2, there we go. So u to the 3/2, and then instead of dividing by 3/2, what do I actually do? I multiply by 2/3. Okay, so now you can see we've got some simplifying that needs to be done. Okay, the 2's cancel. And so on the top, I've got u to the 3/2, which is 2x minus 1 to the 3/2, all divided by what? 3, very good, and then plus c. Okay. All right, I think that's about enough of the new stuff for today. We will continue on. We've got 5 more problems that we're going to hit with this u substitution, okay, and we will continue with that. For now, if you want to go ahead and start working on your assignment, it's listed on your sheet that I gave you. Okay, so pages 304 through 305, you should be able to get a good, healthy start on this. Okay, so